Karibu SolidWorks Tanzania. Yeah, this is a continuation of our industrial automation series. And in our today's presentation, tunaenda kuwa more creative on our control of a conveyor. So initially tulikuwa tuna Siemens program ambayo ilikuwa ina control hii layout yetu hapa ya factory hiyo. Ilikuwa tukipress start, ina start, inawasha na lights, ukipress reset, ina reset, inawasha na light ya reset, but the conveyor was moving at constant speed, right? So now in this presentation we will see how to control speed of a conveyor. So what do we need as an input? We need a start push button as here, and a reset push button. But another thing that we need is a potentiometer, right? So on the operators, we drag drop a potentiometer, and then we hold V on the keyboard to drag this upward, and then we position it maybe there. Okay, so now we have a potentiometer here. All right, but then tunaweza kuwa pia na display ambayo itakuwa inatuonyesha current speed that we are in. So tuta drag drop pia a display like this one, LED display V. Okay, let's put it there. Right, so tumeongeza potentiometer, and we know that a potentiometer inakuwa ni voltage controller. Manake tutakuwa na lowest voltage ambayo ni 0 na highest voltage itakuwa ni 10 ambayo inakuwa provided by the potentiometer. And the way we vary our potentiometer voltage output, we also vary the speed of our conveyor. The higher level of the potentiometer, the highest speed. The lowest level of the potentiometer, the lowest speed, right? This is very useful in packaging lines. How fast do we need our conveyor to go? Okay, isifanye spillover na nini. Kama vitu viko havijafungwa, the conveyor ikiwa too fast, unaona utakuwa na spillover kama, lakini vikiwa vitu vimefungwa, we can put it on a faster speed to increase the packaging speed. Lakini pia inatumika kwenye bottle filling systems, right, material handlings, etc. So initially our potentiometer here, so our potentiometer is an analog input. This one will give us the voltage 0 to 10 volt, lakini kwa wakati mwingine pia tunakuwa na current controller ambazo yenyewe ina give milliamperes, rated 4 milliamperes to 4 amperes, rated 4 to 20 amperes, right? Okay, then we have a PLC controller kwenye Siemens yenyewe itakuwa ina read the input ina convert into output, alafu tutakuwa na kitu kinaitwa kwenye hii system yetu hapa kwenye motor, jua kwamba hii voltage tunayo control kwenye potential hai control voltage inaenda kwenye motor, no. Ina control voltage inaenda kwenye kitu kinaitwa variable frequency drive, na hii variable frequency drive ndo ambayo ina drive motor according to the speed, VFD. Kwa sequence ya hapa ya operation ya control speed ni kwamba you have a potentiometer input, and then a potentiometer will go to a PLC to be interpreted into value of speed. Maana potentiometer inatupa voltage rating 0 to 10, na speed yetu hii convert tuta right click hapa, tutaibadilisha configuration. Before ilikuwa digital, ndio maana kuna start stop button, but now tunaipeleka analog. So hii itakuwa ni analog output, ndio ili iwe controlled na potentiometer ambayo ni analog input, right? So pia highest speed kwenye conveyor ni rated pia according to voltage. Unaona hapa volt V. So ipo rated according to voltage. So unaweza ikawa either 0 volt ama 10 volt. So tukiklik hii potentiometer hapa, hii potentiometer unaona kabisa ukiforce, unaona hapa iko rated 10 maximum. So say run, unaona iko 10 maximum, 10 maximum na unaona hapa. So hapa kuna voltage ratings 10 maximum, minimum 0, 10 maximum, minimum 0. Now our conveyor speed is also rated as a voltage. Okay, so 10 as a maximum, 0 as a minimum. Okay, so vile tuna adjust hapa 0 to 10 na huku pia tuna adjust 0 to 10, so it goes correspondingly with their speed, 10 being the highest speed, 0 being the lowest speed. Alright, na hii LED display yetu, digital display yetu na yenyewe tukiforce, unaona 10 maximum. So ukiangalia hapa inaandika hapa values hizi hapa, so unaona inaandika 10 maximum, 0 minimum. Okay, hizo tunaweza tukaziweka kama data type yake inaweza ikawa real data type. Okay, tukaisave kwenye real data type. Okay, na ambayo ndo screen yetu. Alright, real data type. Okay, na yenyewe inakuwa ni this is an analog output QD, this is an analog input ID, and this conveyor now will be an analog output QD something, right? So okay, kujua I is for a digital input, O is for digital output, ID is for analog input, QD is for analog output. Right, let me have my my emitter and remover not forced. All right, okay, release this, should not be forced like this. Display also should not be forced, do like this. Belt conveyor should not be forced. Okay, so now anything that is not forced can be controlled by the program. So now as we have this set up already, now let's go and see how we can write a speed control ladder logic TIA Porto Siemens program. So come here to Siemens. This was our previous ladder logic network ama PLC program. We can just delete this. So click on network and press delete on your keyboard. Again, this network, delete on your keyboard. All right, so you go to the show all tags. I'll say Control A and delete everything. So now we have new tags. So tukija hapa kwenye factory ya hiyo file drivers, so ni 7 PLC sim, but we know we have our start button as I 0.0, reset button as 0.1, and then hapa kwenye output tuna analog conveyor, so tutaweka kwenye QD. So our analog conveyor should be on QD30 real value, and our display will also be on our QD34 as analog output. Na huku pia tuna analog input ya potentiometer should be on ID30. Okay, like that. So real. Okay, those are real values. So after that, so this is how we should write our tags. So input tuna digital input, digital output, analog input, analog output. So let's start with digital input. So TIA Porto, here we say start push button, and then we have reset push button. Okay, and then we go to the digital outputs. Digital output ya kwanza ni start button light, ambayo ni Q 0.1. Okay, so from here iko kwenye Q 0.1. Then you have reset button light here, reset button light, reset button light as output. Then we have an emitter, digital output. Then you have remover. So hapo tumeshamaliza digital inputs and digital outputs, right? Bado warning light. Okay, here we have a warning light when the conveyor is moving. Okay, after that, now we go to the analog input. So analog input tunayo moja potentiometer. So tutaandika potentiometer ID30 ndo address yake na data type ni real. So hapa tutaandika potentiometer, potentiometer, potentiometer. Data type hapa ni real, real, na hapa address ni QD30 ya QD, okay, ID30 kwa sababu ni analog input, ID30. Then tumemaliza analog inputs. Now we have digital outputs. You have belt conveyor and digital display. So belt conveyor, belt conveyor, belt conveyor, ID30. This now should be QD30, and the digital display. Ambayo ina display values za digital display, ina display values the potentiometer. Ina scale, inasoma values za analog input coming from the potentiometer. Okay? Ndio maana hapa, so digital display inaweza kuwa digital, but kwa sababu hapa inaenda ku read value ambazo zimekuwa input yake imetokana na analog input, maana yake ina display analog values, so it has to be connected on an analog output QD34. After that, what else? So that's it. So tukishamaliza kama hivyo, tunarudi hapa kwenye main. Now we can start writing our program. So let's start by writing our latching network. So latching network. Okay. So on our latching network here, we have an start push button, and then we have our normally close reset push button. Okay, and then we have an output. Then we latch the output here. Okay, so this will be a start push button, and then we have here reset push button, and then we have here, so this one here, I'm taking a memory output, M based memory output. So kuna M 8 bits, MW 16, and MD 32. So I'm taking a binary memory, so M 0.0 tag 1, na hapa pia na carry hiyo memory tag 1 like this. So this one is a latched memory output. Then nitakuja hapa chini now, nitakuja hapa starting conveyor, starting the lights emitter, starting the light emitter and remover. Okay, so hapa nitachukua hiyo memory tag yangu, nitaweka output ya kwanza ya start button light, then nitaweka emitter, then nitaweka remover, and then nitaweka warning light like this. Okay, right. So hapa nitaweka my M0.0 which is my memory tag, alafu hapa nitaweka start button light, then nitaweka emitter, then nitaweka remover, remover, and then nitaweka warning light like that. Okay, inamaanisha start button ikiwa on and this is normally closed, so my memory will be high, memory bit will be high. So then here it will be high, and then this will be on. Then let's say resetting the light, so reset light. So reset light yangu ili iwe active, hapa nitaweka normally close ya M0.0, alafu hapa nitaweka my reset line. So hapa nitaweka M0.0, manake na work vice versa kwamba when the memory bit is off, now a reset light must be on. Okay, and when my memory bit is high, then hapa ita disconnect, then reset button light itakuwa low. Hope you get that. Now on network 5, so tumekuwa na network 2, network 3 and network 4. Okay, on network 5 here, we are going to do the scaling of our inputs. Like tunajua potentiometer inatupa scale ya voltage kati ya 0 to 10, lakini pia tunataka kuiscale into a value of maximum to minimum ambayo inaenda kwenye conveyor yetu, ambayo pia conveyor ni 0 to 10. So kuna block inaitwa normalizing x and scale x. So uta click hapa, alafu hapo utaandika norm, uta select hiyo norm x. So tuna normalize x from the minimum. So the minimum hapa, minimum ni nini? Minimum ni so hii hapa ni hapa tuna scale and normalize. Hapa naandika normalize and scale potentiometer. Okay, so tutakuwa tunasoma integer values. Alright, integer values kwenda kwenye real. Okay, minimum value ni 0, alafu value tunasoma kutoka kwenye potentiometer, maximum value ni 10. Manake potentiometer ndo input ya value kwenye our norm x. Norm x manake hii ni rate ya potentiometer, nasoma between 0 and 10. Output ya norm x huwa normally inakuwa between 0 and 1. So ime normalize. Hata hapa ingekuwa, hata kama potentiometer ingekuwa inatoa, kwa mfano hapa tungekuwa na level meter ambayo inasoma from 0 to 300. Hapa output inge-rate hiyo 0 to 300 in a normal value of 0 to 1. So hapa output yetu tuipe memory tag, tuseme this output is MD30, right? And then output ya kwenye norm x tukaiscale sasa, scale x. So tunaiscale kutoka kwenye nini? Inapokea real na inatoa real. Okay, minimum again. Sasa hii scale value ndo inaenda kwenye nini? Kwenye display yetu, ambayo pia itaenda kuendesha conveyor, si ndio? So minimum value pia hapa ni 0, alafu value tunazosoma hapa ni MD30, value ambazo zimetoka kwenye normalized state from 0 to 10. Hapa natoa 0 to 1, hapa 0 to 1 ina scale our minimum and maximum of our display, ambayo inaenda kwenye display maximum 10. Okay, so hapa output yetu hapa sasa inaenda kwenye screen ambayo ni digital display QD34. Okay, so take this block very serious. So we normalized our reading from potentiometer from 0 to 10, which is our potentiometer reading, to MD30, which is a scale normalized reading ambayo itakuwa 0 to 1. And that's normalized reading, we scaled it from 0 to 10, so as we have it on a digital display that goes to run our conveyor. Okay, then after that, now let's start our conveyor. Conveyor speed control. Now tukija hapa tunakuwa na our memory bit and our move command. So here memory bit yetu ni ya M0.0, and then hapa tuna move, so tuna move value. Which value are we moving? We are moving the QD34 value ambayo ni value ya display iende kwenye QD30 ambayo inaenda now take action on the conveyor. Okay, and now resetting our conveyor, resetting conveyor. So tutaandika hapa program yetu, so tutakuwa hapa na reset push button, alafu hapa tutakuwa tuna move value, move. So hapa tukiwa tuna reset push button, hapa tuna move which value 0.0 to our conveyor QD30. Now conveyor will be off. Yeah, so study this block slowly. So this is for block for connecting TIA port to Siemens TIA port with our factory IO. This is a latching network. We have a memory bit here, high or low. Our memory bit will then go to set our start button light, emitter, remover, and warning light. Then a normally closed the memory bit will be controlling the reset button light. Then we normalized and scaled the potentiometer and sent it to the digital display. And then we wrote conveyor speed control where we, with the memory bit on, we are moving a digital display in to control our belt conveyor speed. So if the display is 1, speed is 1, display is 4, speed is 4, increasing like that and decreasing according to how you adjust your potentiometer. Kwa sababu hii display ina display potentiometer reading. And then we have a reset push button. If we place reset push button, then we are sending a 0 reading to belt conveyor, so the belt conveyor stops. After that, say compile. So 0 errors, and then we go to online simulation, start simulation. Wait on it. Consider as trusted. Wait on it. Wait on it. Okay, so hapa sema load, then say start module, finish. After that, now our Siemens is controller is running. So come here and download this program to our controller. So we download it to our control device and say consider as trusted. Say load, finish, and then say go online. Everything is green here, looks good, then monitor. All right. So now let's go back to our factory IO and say connect. Marvelous. So this is connected. So go back here and they say, you see it is stopped. So stop, then run. So you say if you say start, so you see the conveyor is not moving. So if we scroll the potentiometer, now you see the speed of 1. Our conveyor is moving at a speed of 1. If I adjust again the potentiometer, now our conveyor is running at a speed of 3, faster than before. You see? And here it is displayed speed of 3, speed of the conveyor. Again, if I adjust it, then it's faster. You see? It's even faster, right? Yeah. So if I return it, now it is very slow, very slow. So you see here the speed displayed is 1. Hata ukija huku kwenye TIA portal ku PLC sim, hapa kwenye TIA portal, hapa push button iko pressed. Let's go and see our screen display. So ukiangalia hapa screen display yetu hapa ni 1. Unaona palikuwa 0.1, 0.1 kwa sababu ya hii margin ambayo tusema hapa itakuwa 0 to 1. So now the speed here is 1. All right, and here 2 is 1. That's what runs the conveyor. If I press reset, then the conveyor here will be 0. Okay, so if I press reset push button, so you see the conveyor stops moving and 0 is sent to the conveyor. If we say start, it is start from the speed that was there before. So you can add the speed and moreover. So yeah, that was it. That's it on our PLC, Siemens PLC speed control of a conveyor. I hope you have captured plenty from this presentation, and you are doing great. You are going on the right direction. Keep moving forward. See you on another lesson. Ciao.